All right, welcome everybody to Tech Talk Thursday. First of all, let me thank you all for being a part of this. I am going to be your host for today. My name is Brinda and I am from the People team. I help um, conduct these tech talks. So in case you have any interesting tech talks and want a platform to share your talks, please reach out to me. In today's Tech Talk, we will be discussing the app refresh. App refresh is a journey of how Agoda changed the look and feel of their app. What went into it? What were the challenges that were faced? How did the team come up with the solutions? How does it currently look like? And what are the next steps? For our speakers, we have two very talented speakers today. We have Michael, who is an iOS engineer from the property team, who's curious about latest of the iOS language, that he has made several improvements in Agoda, such as Agoda widget, the property page improvement, and a lot of his work can be found in the Medium blog that he maintains. His articles are also available on Agoda Medium page. So do reach out to him in case you have any questions regarding anything to do with iOS. He's a subject matter expert over there. Also, we have Gaurav, who will be taking the Android approach in this tech talk. Gaurav is an Android engineer who has been with Agoda for a little more than 3 years. Most of this period at Agoda, he has spent in the Viper team, handling the home SSR and related sections of the Android app. Gaurav enjoys reading and cooking. So in case you want some lips packing food, you know whom to reach out to. So without further ado, I will hand it over to Michael. Michael, please take it forward. Thank you so much.
Thank you everyone for attending the April Press meetings. My name is Michael. So in here I will try to giving some update about the front end, especially property team and home fiber team about the progress that we have created about app refresh in general, and then about the there are some agendas here. The first thing is we will talk about the app refresh overview in general. And then the second things we will talk about the technical overview. Why do we use the latest technologies in both Android and iOS? And then how about the new framework of Picasso, how it can replace the DaVinci framework itself. And then the last one, we will talk about the Q&A section. Yeah, for the app refresh overview, I will hand it over to Gaurav for explaining about in general about app refresh. Yeah, next slide, please.
Yes, thanks, Michael. You guys can hear me, right?
Yeah, I can hear you.
Gaurav.
So app refresh is basically an attempt to get the Android and iOS apps of Agoda to a new look and feel. That's the basis of the idea, as the name quite quite a clear name called app refresh. So the basic idea of it is to move the apps into a new UI, newer direction, a fresher UI. As you can see from the screenshots, it's something significantly different from what we have. The other add-on that we managed to get with this was to move the iOS and Android apps into a new state-based UI direction, which is something new for us. So while app refresh was, while the planning phase of app refresh was going on, we also had considerations about whether to use existing systems or whether to move on to new systems, and to sort of take the apps into a kind of a future where we can play with Jetpack Compose and SwiftUI. So further, we'll be talking about how we took the opportunity of app refresh to introduce Jetpack Compose and SwiftUI through a framework called Picasso, and we'll also be giving you an overview of what Picasso looks like. Next slide, please. Yes, for the SwiftUI part, I'll hand it over to Michael again.
Okay, thank you, Gaurav, for the fresh overview about the app refresh. So The first thing first, I would like to give you some information about SwiftUI. So basically, we are working this app refresh is a new opportunity for us for creating our application, especially Agoda apps in the mobile front end. For the iOS part, we are working with the SwiftUI, which is the latest hype in the iOS programming. It is a new declarative UI framework since 2019 from Apple itself, and then it's going to be it's already went stable since 2020 versions, which is SwiftUI 2.0 at the time, and then we have now already the new version as well, and then it's becoming more stable and stable. And then the third point is it is much faster and easier to use because it is a declarative language, so it's easier for us for declaring a view, which is that's why we at first before we created DaVinci, because we want to create a new DSL language to help us as a developer to write a view in a much more easier and understandable manner. And then somehow SwiftUI come in exactly almost in the similar time. I think it's about around a year later, and then we have a SwiftUI, which is right now we think of it that we can actually directly write the code in the SwiftUI for building a view. And then it has a built-in animations from the Apple itself, which is whenever the state changes, it will create slick animations for our iOS apps for free. And then we have next point, it is driven by the state change, which provide more support into a unidirectional flow architecture that we have as well. Another thing is it is a universal language for multi-target. One SwiftUI view code, it can be deployed for multiple platforms like iPad, macOS, watchOS, tvOS, and it is respecting all of the multi-platform layout, which is very powerful for us if you want to write a singular view that can be reused for between all of the target that we want to build, basically. And it is obviously it is reversing languages for all iOS developers, which help for those who wants to take up or step up a new challenge in their day-to-day life in the work related, and then they can jump to learn a new things. And it obviously most of the new developers will be even the existing developers will like to explore an opportunity to write a code in SwiftUI. Last, we also have Agoda widget which is already using SwiftUI already, and it's already production ready. Next slide. Another important thing in SwiftUI is able to inject the old UIKit system and vice versa. So you don't need to worry if you have something that is not available yet in SwiftUI, but you want to use it in the SwiftUI code. You can wrap it into one of the wrapper in the UIKit that you can help you to create the view of the UIKit into a SwiftUI view, basically.
They want to be seen while receiving that feedback, so you can even vary that location based on sort of the appropriateness of the feedback. And sorry.
And then we have another important thing is we can manage the theme so easily. So especially adjusting the dark mode automatically. And then it also provides some mechanism for reactive programming enthusiasts like bindable object binding, and then the whole combined framework. And it also offers a live preview like a hot reload. And then it has a less code to write compared to UIKit, because we don't even need to write a boilerplate code. So let's say example for writing delegate for the data source or defining the view. Okay, so for the Jetpack Compose, I will hand it over to Gaurav, basically. Next slide.
Thanks, Michael. So just like SwiftUI, the Jetpack Compose is also it's offering by the Android platform, which is the modern declarative toolkit for building UI components. The project has been around since 2019 also, but it became stable around July 2021. And because of its timing of stability, it became a viable candidate for consideration while doing app refresh. Like I mentioned before, it is a declarative framework, which is relatively a new concept for Android. Before, we've had on Android, we are used to creating views via XML files or just creating actual view classes. And we were used to that approach. And then we also got introduced to a declarative approach due to certain independent libraries, and also due to efforts inside Agoda itself. So the declarative pattern of creating UI is something that's relatively new for Android. The defining feature of Jetpack Compose is it it's basically both the two-way interoperability that Jetpack Compose interacts seamlessly with the old view systems, and the view systems can seamlessly interact with Jetpack Compose. So with whether you're migrating in small chunks or whether you're doing a big bang approach of migrating your entire view systems to Compose, you can have both approaches, and both of them work fine because you have complete interoperability out of the box. As I've mentioned before, again, it is a state-based system, so it basically allows us a clearer separation of concern between where we write our business logic and where we define our UI. So a lot of the times we have mixtures of concerns where certain things that could have been achieved in a certain things that should have been on a could have been on the business logic side of things had we had the scope of creating that kind of design. But instead, they were sometimes passed on to the view layer, and the view layer was doing a lot of if-elsing, doing a lot of magic. So instead of view just being uh, a non-intelligent layer that just interprets the states that you pass to it, it used to have a lot of mixed logic, and that led us to a lot of that led to a lot of efforts trying to test it, and there were a lot of issues. But with Jetpack Compose, we have the ability to make it unidirectional and state-based, so that makes it easier for us to have a clearer separation of concerns, and also makes it better for us to test, as we basically just need to capture the state that we want to represent in the UI, and that state should give us an idea of what we should be seeing on the screen. Next slide, please. Yes, so the difference, the old systems on Android generate a hierarchy of views. So they create basically a nested structures of views. Jetpack Compose is designed to create and maintain like a tree-like data structures, more like React. So the possibilities of creating flatter structures are more with Jetpack Compose as compared to the previous view system. And like I said, it's fully supported by the Android platform. It is shipped as a separate library, but that's actually one of the reasons why it is completely backward compatible, because like I mentioned before, it's because Jetpack Compose is able to seamlessly communicate with the view systems on Android. It doesn't. It is The view systems are basically what is shipped on Android devices itself with the OS, and Jetpack Compose is an external dependency that is easily able to communicate with the view systems, and therefore it provides seamless backwards compatibility, which is a great thing because of the fragmentation in Android that we have. Agoda itself needs to support versions up to Android 6.0. And the latest version of Android is 13. So that we have that amount of fragmentation. Backwards compatibility is something that's very important for the Android systems. It is it became stable in July of 2021. It's production ready, but it's still maturing. There's a big community, and there's concentrated efforts by Google as well into providing constant and frequent updates for the Jetpack Compose ecosystem. And the effort is not only limited to Android, as I will mention again later, but it is also something that has potential, and in fact it has already certain implementations that make it available for cross-platform use as well. Next slide, please. Yes, so we mentioned DaVinci Framework before, and I also mentioned that we had built there were certain efforts inside of Agoda to build a more declarative UI pattern for both Android and iOS. This effort was called the DaVinci System. So the DaVinci was basically a DSL framework which was built in-house at Agoda that provided us a way to create declarative UIs with UI kit, which is the standard iOS framework, and with the Vue framework, which was the standard Android framework. So I would like to give a shout out to the DaVinci team, which is now the Picasso team, that did a great job with this as well. And it was a great step forward for us. It was a great introduction into declarative UI. So basically, we had a step into the right direction about 2 years ago, which eventually made the transition into Picasso/Jetpack Compose easier, because we were already used to writing certain things the way Jetpack Compose demanded us to write. On Android especially, it enabled us to do snapshot testing, which it was notoriously difficult to create standalone small views and just take a snapshot and have them as a control image and then compare your changes against in the old system. But DaVinci made it very easier for us to do that with self-contained model-based views that you just pass the model to, they render, and you get a snapshot. So that was a big step for Android. iOS already had snapshot testing, but Android that was a missing section on Android, so we were able to achieve that with DaVinci. Since it was an in-house system and it was developed 2 years ago, and it had like a limited pool of contributors into it, which was not the intention, but that's how it ended up happening. There were certain drawbacks that that were a part of the DaVinci system. It was sometimes hard to build some complicated UI designs, or to introduce animations into DaVinci. Animations was in fact one of the big considerations that we had while trying to start App Refresh, because um, the input was that we need to make the look and feel of the app fresher, and animations are an integral part of that. So if we were to stick with DaVinci, we would need an extra effort in order to get those animations and working with DaVinci. And hence, instead of putting the effort into that system, we decided to switch over to a new system that would support Jetpack Compose and SwiftUI, known as Picasso. Picasso is again a internal Agoda framework that is built around Jetpack Compose and SwiftUI that provides certain components for us and gives us certain rules to play with while we create our UI. Next slide, please. Right. So the DaVinci versus Picasso. So DaVinci provided us a new pattern. That is, it provided us a DSL that we could play around with and create our views. So it provided a language in which we could create our views. Picasso doesn't do that. Picasso is a framework that builds on top of the existing frameworks of SwiftUI and Jetpack Compose. That it basically pre-packages certain things for us and gives us ready-made components in some cases, and in other cases it allows us freedom to build what we want, but it also gives us certain rules to play within the bounds of. So the idea behind Picasso was to promote as much reuse as we can, while also limiting certain things that developers might do to get out of the bounds of what actual Agoda design language demands. So in a way, it is a way to enforce the design language system. So we have a whole design language defined for the mobile platform. So if we say we need Excel padding for something, developers, designers, and everyone involved knows what that Excel padding actually means. So we found that was done in DaVinci, and that design language definitions were carried over into Picasso. Another aspect of this is the language that we write in. Like I mentioned before, the DaVinci provided a DSL of itself, so it had its own it had its own way of declaring things. It had its own syntax nuances. Whereas with Picasso, we have, since it is built on top of Jetpack Compose and SwiftUI, we as Android developers, we still use Kotlin. As iOS developers, we use Swift. So the learning curve for a new DSL was lower, and while at the same time we got a lot of advantages of out of the box animations and other like community support, and we could also basically keep our snapshot testing frameworks and everything still. So we got the additional advantages of moving forwards in terms of how our code base is. We got the advantages of getting animations built in while also keeping the snapshot systems and everything else in place. To summarize, DaVinci was a system that provided rules and it had certain boundaries. So the design language served as the rules through which you can create things, and the boundaries were defined by what the DaVinci framework itself could do or do not do. For example, like animations. Picasso isn't limited by those kind of boundaries. It is, you are free to implement what you want as long as you as long as you play within the rules of the Agoda design language. And that like that. So while it gives us a freedom to create what we want to, as long as we play with the rules that have been provided through the design language. And that I feel is one of the like step ups that we have from DaVinci in Picasso. Next slide, please. Right. So this slide kind of represents the evolution of how views look on Android. So on the extreme left is the XML files that we use to define our views till we had DaVinci about 2 years ago. So and we in certain cases it still happens that we need to modify the XML files for creating a UI. So on the extreme left is what it looks like. On the in the second snapshot is a Jetpack Compose component. So as you can see, the Jetpack Compose is more like a declarative. It is it's a bit more concise than DaVinci, which is on its right. So there's like slightly easier. The third snapshot represents how DaVinci views looked. So as you can see, it's already a step up from the first snapshot of XML, and it already provides a more readable, more understandable way of what's happening. And you can, since it's in Kotlin, it was also easier for us as Android developers to understand to further do some things that we couldn't do in XML. And in the middle is on the second snapshot, I mean, is Jetpack Compose, which is even a step up ahead of what DaVinci provided. And on the extreme right is a version of SwiftUI. So as you can see, probably SwiftUI and Jetpack Compose have quite a lot of similarities. In fact, DaVinci, if I had put a snapshot of a DaVinci component that was built for iOS, it would also have certain similarities with how DaVinci components were built on Android. So it was not a direct one-to-one similarity, but there would be certain factors that would be similar. So it would also promote understanding between platforms. So if you understood what, for example, a gradient means in the DaVinci language, you could understand what was implemented in iOS and Android. And the same goes for, and a similar thing happens with Jetpack Compose and SwiftUI. If you can understand something implemented in one of them, you can possibly understand something implemented in the other, because it's basically it's around, again, not one-to-one exactly the same, but it is kind of similar and more and easier to understand. Next slide, please. For this one, I would like to hand it over to Michael.
Okay, cool. Thank you, Gaurav, for the explanation about the DaVinci and Picasso. So for from all of those things, technology things that we have built for the app refresh, we can kind of get some of the benefits of what we are doing right now. So the benefit is one of them is improving the velocity, especially when we want to create kind of UI complex layouts. It can be achieved faster than before because of the easiness of the usage of the SwiftUI and the Jetpack Compose itself, which has a lot of technical things that is not quite hard to achieve. And the next thing is about the easier separation of concerns allows focus on the business logic, which we can heavily thinking more about how do we create the flow or the core logic of the things that we want to build. And then the next thing is about the less crash on the UI layer, because mostly the crash that we used to write before with imperative programming, we need to create kind of step-by-step things, how to create a user interface. And then in iOS, we have kind of auto layout, which is we need to bind the constraint between each layout between one and another. Meanwhile, in the SwiftUI view, it will be automatically composed together, and we try to adapting the layout with the available size on the view layer itself. And then the next thing is about the unidirectional flow, as we talked in the beginning, because since the UI reflects the change based on the state that we provide. And then lastly, we have support with the Taga. As you know that we have another framework we call it as a Taga. When most of the team right now trying to migrate from Fiber into Taga, which is very helpful for us, because Taga is having the good unidirectional flow that we can store the state in a specific store, and also the action that we can also dispatch in the correct place for both iOS and Android. Next slide, please. And then, but we also thinking about some drawback that could happen because of the new technology that we implement for both iOS and Android. The first thing first, some limitations of animations that we need to customize it. Even though the iOS give us a lot of built-in animations, but at some point, if the designer say that we need to customize things that are very hard to do, basically normally it's very easy in imperative programming, because we can step by step declare what we want, and then we can try to do some tricky, some magic of the UI layer. But in SwiftUI, the resources is just quite lack at the moment, and how to do it properly. Sometimes we need to do some hacky things in the SwiftUI view layer itself, and then it could lead to unexpected bug that can occur at some point. And then the next thing is about the steep learning curve at the beginning, especially for the new developers. It might be easy language to learn, but for the new developers or even the existing joiners or existing developers, it could be need some time for learning the way to declare a view in the SwiftUI view. And then the next thing is for iOS, we need to drop the iOS 13 and below. Why? Because even though SwiftUI start from iOS 13, but the SwiftUI 1.0 is quite not stable. And then hence Apple provide a new version, which is SwiftUI 2.0, which only support iOS 14 and up. Then we need to briefly drop iOS 13 and below at some point. And then the fourth point is we need to when we want to debug in SwiftUI view is quite challenging, especially the view hierarchy feature is not working well for it. And then we need to find more creative way to debugging the SwiftUI view. And as I mentioned in the point number one, the unknown crash can occur, and little resource to help find the root cause. And then lastly, the both frameworks, both SwiftUI and Jetpack Compose is still maturing. So maybe in the next version, it could have some different API or maybe different way to do things. We need to, the current API may be deprecated and easily changed with the new way as well. Next slide, please. Yeah, so for the state of the future that we are going to do, I will hand it over to Gaurav for this one.
Thanks, Michael. So as we mentioned the word state a few times before, and because we mentioned also that we possibly carrying with this new approaches of Jetpack Compose and SwiftUI, one of the ideas was to carry the apps into the future as well. So I would like to talk about how the general ecosystem of the mobile apps mobile apps in general and specifically at Agoda might look like. So one of them is server-driven app architectures. So because we now have a framework that can basically have that maintains flatter tree-like structures, we can have is a framework where a server defines what elements we need to draw where, and the app only react as an interpreter of the data that the server provides, and basically acts as just as a rendering engine, basically like a browser, and just renders whatever instructions the server has given. So a server gives a response of saying on this page in this section draw a text and an icon, and the app just reads that, responds to it, creates a text and an icon through your through Jetpack Compose and through whatever Compose and SwiftUI, and just renders it. So the possibility is with these two frameworks is more than it was before. In fact, at Agoda, there is, as many of you might be aware, at Agoda we have an effort ongoing to introduce server-driven UI. And if you guys are interested in checking out what is going on with server-driven UI, and maybe if you are interested in trying to contribute to it, there is a Slack channel that I mentioned here, SDUI Workgroup Public, that is basically a public forum for discussing ideas and checking out what's going on the server-driven UI world. So the current status of that is we're still trying to set up the initial requirements for a server-driven UI. So the whole process is still ongoing. We have certain milestones, but you can catch up into that group on Slack if you are interested in this project. On specifically speaking for Jetpack, specifically speaking for Compose, the Compose ecosystem has matured a lot to the point that we now have something called Compose multi-platform, and we have also which is Compose on the web and Compose on desktop. So there are separate projects, separate efforts at JetBrains to create Compose as a whole ecosystem for basically a standardized ecosystem for creating UI for the various platforms that you need to target. Jetpack Compose is just one of those implementations that specifically targets Android. Compose for web and Compose for desktops are two other efforts that help us target for the web and desktop applications. That there are a lot of community projects around that. So yeah, so that's another interesting thing for the future. There might be there is another related thing that's called Kotlin multi-platform. Many of you might be aware of it. So Kotlin multi-platform basically is an effort again to have a single Kotlin-based code base, and then that basically helps you support both your iOS and Android applications. So this is a step ahead from your something like React Native and your common code base in Kotlin, and something like Jetpack Compose, something like Compose, the UI platform basically that can help you then render your UI onto whatever platform you support. So these two things are especially very interesting and to look for in the future. And the last thing is, as you I've mentioned certain resources where this becomes more clearer, but Jetpack Compose is a more React style system so there is a possibility of creating React like hooks, and therefore the adoption of React style architectures on mobile platforms is might see an uptick. Internally at Agoda, like Michael has already mentioned, we have a platform, we have an architecture called Taga, which is one of the examples of the kind of React style architectures we might see. So yeah, that is another thing that we might see, that adoption of React style architectures on mobile platforms will grow up. Right now, mobile platforms do not tend to do things like React hooks, but that might go up in the near future. Next slide, please. Yes, so this is our progress to date. The iOS, we've run the experiments for app refresh on iOS homepage, Android homepage, and on Android, we've also done the property gallery. Both these experiments have been taken for homepage for iOS and Android. Both experiments have been taken and are running at the moment, running live at the moment. Also, the gallery experiment on Android was also taken. So we've had a good amount of success with trying to migrate from the old systems to the new systems, and also our new designs seem to have had a good impact on trying to uh, take the app ahead. What you will see in the future, we have right now, we on the Android and iOS side, we are trying to get through the SSR section. So very soon you might be able to see the SSR card in a revamped manner, while the other parts of the page are still in progress. So and also the property page on both Android and iOS is also an implementation is in progress. So you can keep an eye out in the future for these new designs. Next slide, please. Yes. So now these are some of the additional resources. There's these are mostly videos that help you understand basically help you understand Jetpack Compose, but most of these concepts can also be applied to SwiftUI, because both of them are state-based UI framework. So if they only differ kind of syntactically in some areas because they're implemented on different platforms and in different languages. Otherwise, conceptually, more or less, they align most of the times. Next slide, please. Yeah, this is again more of the same. We have a lot of resources. The last one that I would like to mention, the Kotlin Slack community. So, like I said before, there's Kotlin, and I am an Android developer, so I know mostly about Kotlin and the Java community. So there is a Kotlin Slack community there where you can join and find more information about Compose, the Compose desktop that I mentioned previously, and Compose web as well. So please check out these resources, and also if we can help you in some way to understand more, please let us know as well. And yeah, that's it for us talking. Now, if you have some questions, feel free to ask us.
You guys mentioned React style architecture. I'm wondering if you have like the same state problem that React does, and if you're going to have like a state store or something like that, or what are your plans there?
Michael, do you want to answer that? I think Michael has more experience playing with Taga than I do. I think Michael probably can take that question.
Yeah, I think for answering about the React style of state, in this one we are working with Taga, which is a framework has been created by Ambas initially, and I'm not sure if he's on the Slack channel. So the reason behind creation of Taga, it was having the pattern of a kind of reducer, which is I believe is something almost similar as a Redux pattern in a React in a website. And mostly, but probably it has a slightly different style of writing the store and reducer and dispatching on actions. Hence, recently we try to improving things to try take a look into the implementations of the Redux on the from the front end teams, which several member has been talk with the front end team to think how to improve the current Taga framework, which is beyond the capability of both me and Gaurav. But what we have seen so far, we created kind of a state-based based on this kind of Taka architecture. And we also put a kind of additional resources. If you can see in this slide exactly, the first one is the composable architecture. This is the thing behind the scene why we create the Taka. Most of the Taka we create on top of this architecture, but we enhance it some part of it to be fit into what we want to achieve, basically. Yeah,
so you built something that's based on reading.
Yeah, we built something similar, maybe with some slightly differences, which me doesn't really know the deep down what is the differences. But because I think Ambas was creating this one on top of the composable architecture, maybe Gaurav, do you know some of it probably?
I haven't actually had a lot of experience with that. That's why because you work with it, I've asked. But maybe we can get back to you. We can get a detailed answer of that and get back to you on that.
Yeah, sure. Thanks.
Any other questions? Okay. Thank you all for attending this Tech Talk. See you next Thursday. Have a good day. Bye-bye.